Okay, hydrocarbons are made up of a lot more than just alkanes and alkenes. I mean, octane, that's great. And they obtain all of these things, the anes and the enes, by something called fractional distillation, where they get the petroleum out of the ground and then they distill it. And as it heats up, the stuff that's very light and has the lowest boiling point will rise to the top and they can siphon it off. So that's how they get all the different things out of the petroleum. That's known as fractional distillation, and there's a nice picture of it in your book. Okay, but today we're going to talk about functional groups that change these regular plain old chains into something different. Functional groups are groups that are stuck on instead of hydrogens, or if you break a chain apart and stick something inside, or if you combine two of them and they react and they're linked by a certain chain. So let's go ahead and talk about the different functional groups. First of all, you have things called alkyl halides. Remember I talked about an alkyl group, which was just basically a carbon with 3 hydrogens? Well, if you replace one of those hydrogens with a halogen, like fluorine or chlorine, you have an alkyl halide. A lot of these, and you can attach, you can make long chains of carbons that have halogens stuck on there, because don't forget, halogens, you know, they attach to one thing, and carbon has 4, so you can plug in a lot of different things, but halogens particularly go in there. Teflon is something made, it's made with fluorine. It's a long chain made with fluorine on there. So you get all kinds of different things, and we'll talk about them when we talk about polymers. But alkyl halide is one group, and an aryl halide is when you stick a halogen onto an aromatic hydrocarbon. Okay, so that's called an aryl halide. Now let's get to the nitty-gritty ones. First is what's called an alcohol group. This is what makes your isopropyl alcohol. So how many carbons do you think are in isopropyl alcohol? Okay, prop is the prefix for 3. So iso, I forgot to mention in the last one, but isomers are the different shapes you get. Remember I talked about in the first video how you can get many different shapes even if it has the very same formula? Well, an isomer is something that has the same formula but a different shape. So isopropyl alcohol means it has a different shape than just propyl alcohol. So alcohol group is what's called a hydroxyl group. It's an oxygen and a hydrogen. Hydrogen, oxygen, hydroxyl group. Okay, it's an O with an H attached, and the other attachment, because there's 2 places it can bond, is to the carbon. So an alcohol is a hydrocarbon that has an OH stuck. So ethyl alcohol will be 2 carbons, and instead of one of its hydrogen, it would have an OH stuck on the end. Methyl alcohol would be 1 carbon with an OH. Okay, ethyl alcohol is wood alcohol, and that is the drinkable one, although you don't want to drink too much of it. All right. Polyhydroxyl means it has more than 1 hydroxyl group, and you'll find that a lot of sugars are polyhydroxyl. They've got a couple of OH or many OH groups stuck on them. That's poly for many. Then you have what's called an ether. You've probably heard of ether. They used to knock people out, and in the old movies, they'd come behind them with ether on a handkerchief and stick it over their nose, and they would pass out. Well, anyway, ether is an oxygen that's stuck between 2 carbons. So you can identify an ether because it's just an oxygen stuck inside the chain. All right, it's not stuck at the end. It's in between 2 carbons. Then we have aldehydes and ketones. And you've heard of formaldehyde. It's a preserving thing. Anything that ends in the word aldehyde has aldehyde groups in it. And an aldehyde group is basically a double bond O, which the name of that double bond O is a carbonyl group, okay, or carbonyl group. And so when you have a double bond O, that's a carbonyl group. So an aldehyde has a carbonyl group and a hydrogen stuck on the end of it. Ketone is when you have the carbonyl group stuck inside the carbon chain. So it's not at the end and there's no hydrogen attached, because if you look, 1, 2, 3, 4, all 4 of that carbon's bonds are tied up. So there's no hydrogen involved with the ketone. I like to remember ketone and carbonyl groups because to me it looks like a little key. So here's the top and there's the part that you stick in. Anyway, ketone, the carbonyl group, to me looks like a little key, and that is where you would put it. So anything that ends in "-one" is probably a ketone. Cortisone, things like that would have ketone groups in them. Next is something called carboxylic acids. And if you remember, organic acids are the biggest group of acids and they're weak acids. And carboxylic acids have a carbonyl group on them and an alcohol group. So they form COOH. A lot of time when you see them written, it'll be written like this. Or you'll actually see the formula with the OOH on the end. That means that it is an alcohol. So, carboxylic acid. So citric acid is an example of a carboxylic acid. Formic acid, what makes you get hurt with a bee sting, is a carboxylic acid. So those are formed when you've got a carbonyl group and an alcohol group, a hydroxyl group. If they have between 15 and 20 carbons, then you end up with a fatty acid, which is a fun word to say, fatty acid. 3 fatty acids put together would be triglycerides, okay? A fatty acid salt is soap. So fatty acids are just longer chains of carbons with an acid ending. Next is an ester. Esters usually have nice smells or just smells in general. Esters are made by taking an alcohol and a carboxylic acid and combining them so that the hydrogen comes off the end of the hydroxyl group and you attach it to another chain of carbons. So this is going to be in between. It's kind of like the link. The ester is the link between 2 other things. So you might get wintergreen smell or apple smell when you mix something like methyl alcohol and butanoic acid. So that's how you form an ester. That's called esterification when you form an ester. And the result is an ester. It's when you take an alcohol and a carboxylic acid, put them together, and you get an ester and a water molecule. Okay, because you lose the H from this and the OH from the, you lose the H from that and the OH from the alcohol, and it forms water. So basically it's almost like a neutralization reaction, because soap is, like I said, a fatty acid salt. But ester, that's slightly different. Sorry. Okay, an amine. Amine, you might be familiar with the term amino acid from chemistry. Well, those are what build our proteins. So an amine and amide, those are groups that are attached to your hydrocarbons. An amine just has a nitrogen at the end, and of course it's hydrogens too. An amide has a carbonyl group on there and a nitrogen. So that's the difference between an amine and an amide. So if you're asked to identify which group it is, just look for the different groups and how they're put on there. There's a very nice chart in your book that's very helpful. All right, as soon as I find it. On page 475, that'll help you to identify your groups.